Hi friends, welcome to Learn Engineering with Mira. Today we will solve a problem on truss using method of section. It is a quick method to find out forces acting on some particular members of truss. So let's see the problem statement. Number of Warren trusses with vertical members are used to support this bridge. And we want to find out forces acting on some of the members of one of these trusses using method of section. So let's have a look at the given data. For reference, give the joints some name. Suppose length of these members is 3 meter and height of truss is 4 meter. Due to the combined weight of structure and vehicles, external load of 6000 Newton is acting on lower joints of truss H, G and F. Then find out the forces acting in members CD and GF. The first step in this method is to find out support reactions. Here at joint A, there is a hinge support, so there will be two reactions, RA in vertical direction and HA in horizontal direction. At joint E, there is a roller support which restricts only vertical movement, so there will be only one reaction RE. Before we begin, let's remember the sign conventions we are going to use. Upward force will have a positive sign and force acting in downward direction will have a negative sign. Similarly, anti-clockwise moment will be positive while clockwise moment will be negative. Now consider the free body diagram of the truss as a whole. For this, consider only the external forces and reactions and ignore the forces acting on members. Now, there are three equilibrium equations available to find out reactions. First equation is summation of horizontal forces is 0. So, HA is equals to 0 because there is no other horizontal force acting on the truss. Now, sigma FV is equals to 0. Forces in upward directions will be positive, so RA plus RE, and all the external forces acting on joints H, G and F will be negative, and this is equals to 0. We don't know the value of RA or RE yet, so move to the next condition, that is sigma MA is equals to 0. We know that moment is force multiplied by distance. Suppose joint A is fixed and only RE is applied. It will rotate the truss in anti-clockwise direction, so we'll have a positive sign. Distance of RE from joint A is 12 meter, so RE multiplied by 12. But if only 6000 Newton force is acting at F, truss will rotate in clockwise direction, so it will have negative sign and its distance from A is 9 meter. Similarly, take moment of 6000 Newton forces at joints G and H and summation of all these moments is equals to 0. So we get RE equals to 9000 Newton. Put this value in above equation and we get RA equals to 9000 Newton too. Next step is to cut the truss into two separate parts by section line. This section should pass through maximum 3 members with unknown forces. If no particular member is given in question, you can select any subsequent 3 members even if they are not parallel to each other. But here, as it is asked to find forces in members CD and GF, the section line must pass through these 3 members so that truss will be divided into 2 parts. Next, we have to locate forces at all the cut members, assuming that these are the internal forces acting in members. The force can either be tensile or compressive. Let's assume that all the forces are tensile. Name the forces like FCD, FGF, etc. nearest joint first and then joint at other end of member. Now select any of these two parts of truss for analysis. Result will be same for both parts, but to make the calculations less complicated, try to select the smaller part with less number of external forces. So here let's select this one for further analysis. So now find out all the unknown forces by using equilibrium equations. But before that, if any of the selected 3 members are inclined, find out the angle they make with x or y axis. Here DG is an inclined member and let's say it makes theta angle to y axis. Now in right angle triangle DGF, the length of opposite side and adjacent side is given. So use equation of tan theta and we get theta equals to 36.87 degree. Now let's get back to the force analysis. We know that we have 3 equilibrium conditions. First, we will solve for the condition sigma m is equals to 0. Now, to select the joint about which the moment is taken, out of the 3 unknown forces, select a joint where at least 2 of them are meeting. Here at joint D, line of action of 2 unknown forces FDC and FDG are meeting. Also, line of 6000 Newton force is passing through the same joint. So if we take moment about joint D, moment of these 3 forces will be 0. And now we will have to worry about unknown force FFG and reaction, that is 9000 Newton force only. Now let's think that joint D is fixed and only FFG is applied. It will rotate the truss in clockwise direction. So it will have a negative sign. Also, the distance between joint D and force FFG is 4 meter. So moment will be minus FFG into 4. Similarly, 9000 Newton force rotates the truss in anti-clockwise direction and so will have a positive sign. And its distance from D is 3 meter. So moment will be 9000 into 3 and summation of both moments is 0. So FFG we get is 6750 Newton. Next condition is sigma FH is equals to 0. So let's first write the components of inclined force FDG. As we have already calculated angle theta it make with y-axis, the components will be FDG sin theta and FDG cos theta along x and y-axis. Now these are the forces acting in horizontal direction. So let's add them up because they are in same direction. There are two unknown forces in this equation. So let's move to the next condition, sigma Fv is equals to 0. And we get this equation. Here 9000 Newton is acting in upward direction, so it is positive, but other two forces are in opposite direction, so we'll have a negative sign. Put theta is equals to 36.87 degree, and so FDG is equals to 3750 Newton, and put this value in above equation and we get FDC is equals to minus 9000 Newton. In problem statement, it is asked to find forces in members CD and GF. So the force in CD is FDC, that is minus 9000 Newton. Now as we have assumed that direction of all the forces is tension, negative value here indicates compression. So simply remove the negative sign and write compression or C instead. Similarly, force in member GF is 6750 Newton, which is positive. So assumed direction tension is correct.